Good afternoon, students. Today, our topic is pipeline. First, we'll study the definition of pipeline. Pipeline is a technique of decomposing a sequential task into subtasks. These subtasks are being executed concurrently with all other stages, and these stages are synchronized by a common clock. This is the definition of pipeline. Next, we'll study how it increases the speed of execution. Here, several instructions are executed on different stages of the pipeline simultaneously. Thus, execution of several instructions are overlapped in the pipeline, giving the increasing rate at which instructions are being executed. Let us take an example. The example of a pipeline process will be the assembly line in an industrial plant. Here, a job passes through various stages of the assembly line, and in each stage, a part of the job is done, and then it is passed to the next stage. When it is passes through the last stage, it gets completed, and finally, finished product is rolled out. Let us take another numerical example. Suppose in a class there are 100 number of students, and each student given 5 questions, and each question evaluation time is 5 minutes. Our question is total copy checking time. We will solve the question by two approaches. Approach 1. Employ one examiner in the system. When you employ one examiner in the system, the total copy checking time will be 100 into 5 into 5. That means 2500 minutes. Now, in approach 2, employ 5 examiners, and each examiner is specialized for a single part of the question. We have to evaluate in approach 2 the total copy checking time. Let us, here is your employee 1, employee 2, employee 3, employee 4, employee 5. Here is your time. Suppose at 10 o'clock, employee 1 will check the question of student 1. S1 means student 1, question 1 means first part of that question. At 10:05, employee 2 will check question 2 of student 1. At that time, employee 1 will check question 1 of student 2. At 10:10, this will transfer to this one. This will come to S2, Q2. Here is your S3, Q1. At 10:15, in similar process, S1, Q4, S2, Q3, S3, Q2, S4, Q1. At 10:20, it will be S1 Q5 and H2 Q4. This will be S3 Q3. This will be S4 Q2. This will be S5 Q1. At 10.25, it will be out from the system. So here the total copy checking time will be 25 plus 100 minus 1 into 5. How it comes? At 10.25, the question of student 1 is completed. So for the first question, the total copy checking time will be 25 and there will be remaining 100 minus 1, that means 99 students in the system, and for each student the copy checking time will be 5 minutes. So total copy checking time will be 25 plus 100 minus 1 into 5, that means 520 minutes. So this is the numerical example of pipeline. Next, types of pipeline. There are two types of pipeline. Number one is synchronous. Number two is asynchronous. In case of synchronous, here clock latches are used to interface between the stages. Suppose this is your synchronous pipeline. Here is your stage 1, stage 2, stage 3, and before stage there will be some latches, and these latches are connected with a clock signal. When the value of the clock signal is high, all the latches will transfer the data to the next stages. The latches here are made of flip-flop, and the latches are used to store the intermediate result. So this is the synchronous model of pipeline. Next one is asynchronous. In case of asynchronous, there is no concept of clock. So the question arises, how the stages transfer the data among themselves. This is stage 1, stage 2. In case of asynchronous model, it follows the handshaking mechanism. Suppose stage 1 wants to transfer some data to stage 2. First it will check whether it is busy or not. Next, when it will free, it will acknowledge stage 1 that I am free. Next, stage 1 will send the data. Next, stage 2 will give him acknowledge that it has received the data. This is called the asynchronous model of pipeline. Now, the next concept will found the different function of pipeline. Number 1. What is clock cycle? Clock cycle can be defined as the time within which instruction must be executed. That is called clock cycle. It is denoted as tau. Tau means tau m plus d, where tau m means maximum stage delay, d means latch delay. So this is the definition of clock cycle. Next we will find the pipeline frequency. What is the definition of pipeline frequency? It means maximum throughput of the pipeline. It is used to measure the performance of the pipeline processor. It is denoted as F, which can be represented as F equal to 1 by tau. Next, what is speed up? Speed up means time to execute n number of tasks in k stage non-pipeline processor by time to execute n number of tasks in k stage pipeline processor. It is denoted as a suffix k. So n into k into tau, what we will get? The time to execute n for n number of tasks, k for k number of stages, and here is your clock cycle by the same process is executing in k stage pipeline processor. At that time it will be k into tau plus n minus 1 into tau. By simplification we will get nk by k plus n minus 1. This is the definition of speed up. Number 4, efficiency. What is efficiency? Percentage of busy time span over total time span. It is defined as EK, means Sk by K. After simplification or after putting the value, we'll get n by k plus n minus 1. Next, what is throughput? Throughput can be measured or throughput can be defined as the number of tasks completed per time unit by a pipeline processor. It is denoted as W. W means EK by tau. That means efficiency by clock signal. After putting the value, we'll get n by k plus n minus 1 by tau. So, this is the definition of different function of pipeline. In the semester, there will be different question on basis of these. Question number 1 will be, suppose in a system there are 20,000 instructions. It will use the 5 number of stages. That means the value of k will be 5. The frequency is given here as 40 megahertz. We have to calculate the throughput, speed up, clock period, and efficiency. To calculate the speed up, we know that the formula of Sk equal to nk by k plus n minus 1. We'll put the value here. The value of n equal to 20,000. The value of k equal to 5 by 5 plus 20,000 minus 1. So we'll get 49.90. Similar way, we get the value of efficiency. Efficiency is denoted as Ek, that is defined by n by k plus n minus 1. After putting the value, we'll get the result as 0.99. Next, we'll found what is throughput. Value of throughput will be n by k plus n minus 1 by tau. We'll put the value in the same way and we'll get the result. And clock period will be tau equal to 1 by f. That means 1 by 40 megahertz. That means 0.025 megahertz. So this is the solution. Let us take another example. The problem is that in a pipeline processor there are 4 stages. Stage 1 delay equal to 60 nanosecond. Stage 2 delay equal to 70 nanosecond. Stage 3 delay equal to 80 nanosecond. Stage 4 delay equal to 90 nanosecond. Here latch delay is given as 10 nanosecond. We have to calculate the clock period and frequency of the pipeline as well as speed up. So first we know that to calculate the clock period, the formula is maximum stage delay plus latch delay. Maximum test delay required means 60, 70, 80, 90. The maximum value is 90 plus last delay is 10. So total we'll get 100 nanosecond. We'll get the value of clock period equal to 100 nanosecond. From that we'll find f equal to 1 by tau. That means frequency equal to 1 by tau. That means 1 by 100. Next, the speed up will be, the task will be executed in a non-pipeline processor. To execute the task in a non-pipeline processor, the total time will be 60 plus 70 plus 80 plus 90. And the same task is executed in pipeline. Then the total time will be 100 because we get the value of the clock period equal to 100 nanosecond, and we know what does the clock period means. Clock period means maximum time taken to execute an instruction in a pipeline. So we'll get 300 by 100. That means total speed up time will be 3. So in today's lecture we get the summary of what is pipeline. Number 2, we get how it increases the speed of execution. Number 3, we get an example of pipeline system. Number 4, we get model of pipeline, synchronous, asynchronous. Next we'll find different function of pipeline. Under different function there is clock period, frequency, efficiency, throughput, speed up, etc. Number 6, we'll solve 2 numerical problem. So that is the summary of this lecture. Thank you.